we can only go so far with a sorted set of data. A much better way to make sense out of the data is to use the data analysis tool pack. So in order to do this, you need to go to Data, and then Data Analysis should be available in the Analysis collection of tools. And then go to Descriptive Statistics and OK. And Input Range. So here's my data. So I actually know this is in A1 to A100. Can you see here I've got a label in the first row, marks. So I need to have this box here, labels in first row, clicked. And I'm going to put the output range into the same workbook. When you do this, when you click on output range, make sure that you then click in this box here for output options. And then I'm going to choose, I'll put it into, let's say, F1. And I'm going to click on Summary Statistics and then click OK. And there is my descriptive statistics. I've got the mean, which is the sum of all the values divided by the number of individuals that go to make it up. I've got the median, 49.785, which, lo and behold, is exactly the same as the median that I calculated from a sorted set of data. The mode is the peak in a histogram of data. We haven't covered histograms yet, but one of the problems with the mode is that the calculation of the mode depends on how you actually draw up your histogram. You'll see how this is affected later. We also have the standard deviation. In the same way that we have a measure of average associated with the ordered set of data, the median, the corresponding average for the arithmetic mean is the mean here, and for the ordered set of data we could have chosen the semi-interquartile range as a measure of dispersion. The most useful measure of dispersion for looking at the data is the standard deviation, and the sample variance is just the square of the standard deviation. We also have the range, 71.6, which is exactly the same as we could have computed from the ordered data. But we have these two other parameters as well, kurtosis and skewness. They're a bit difficult to actually describe until you actually draw up a histogram. So I'll discuss those a little bit later when we start looking at histograms. So kurtosis is related to how fat the histogram is in the tails. Skewness is related to whether it leans over to one side or not. But again, you actually need to see these in a graph for them to make sense to you. And we've got our minimum and maximum, as we did before, and a sum and a count. So the count's useful just to make sure you've actually got the right number of data points in there. One final point about skewness and kurtosis is that provided that skew and kurtosis are within +1 to -1, you can reasonably assume that your data is more or less normally distributed. This will make a lot of sense later, but it will only make sense when I actually show you what the histograms actually look like.